Okay, we're on to question 7, our first context and applications question, 50 marker. Celtic Designs Limited are designing a logo for their new company. They've decided upon a shape and are planning their merchandise as illustrated by the shaded region in the diagram below. The triangle XYZ has XY equals 6 centimeters. So there's quite a lot of information here. XY is 6, YZ is 9, ZX is 4. So they all correspond to these three sides here, and the angle is alpha. So the angle at x, so ZXY is alpha. The point W lies on the line XY. The circular arc ZW is the major arc, which is this part here, the major arc of the circle with center x and radius 4 centimeters. Show that to three significant figures alpha is equal to 2.22 radians. So the very first thing you should do is change your calculator into radian mode once you've got to this part of the question. Okay, you take a breath at this stage and you say to yourself, okay, how am I going to do this? Well, you look at your triangle, you see that you actually have a triangle with three sides and you're looking for an angle alpha. So because we have three sides and we're looking for an angle, we're going to use cosine rule. So we know that 9 is across from alpha, so 9 is going to be by itself here on the left-hand side. So it's 9 squared equals 4 squared plus 6 squared minus twice 4 times 6 times cos of alpha. I'm going to isolate cos of alpha step by step, so I bring over the 4 squared and the 6 squared. Well, really what I've done is I've actually brought all this over onto the left-hand side, making a positive, and I actually brought the 9 squared over here, making it negative. So that's what's happened there. I've now divided across by the 2 times 4 times 6, the coefficient on cos of alpha. That's minus 29 over 48. I get the inverse cos of minus 29 over 48, and I get myself an answer of 2.2195160005, but it's asked me to show that it's equal to 2.22 radians. So I have that correct when I round it to 2 decimal places. And that was equal to, or worth, I should say, 10 marks.
So this one's marked on a 0, 4, 8, 10 scale. So low partial credit here for 4 marks is work of merit. So that's some substitution into the cosine rule. So if you have correctly substituted any of the parts in, so if you'd mixed up the 6 and the 9, say at the beginning, but you had the 4 squared in the right place on the right side of the equal sign, that would count as substitution into the cosine rule and would get you 4 marks here. High partial credit is correct use of the cosine rule, so having it correctly substituted in, but you either stop or you got the incorrect answer. So that would be high partial credit here for 8 marks. And this is a start question, so -1 for a rounding error, so 9 marks if this was rounded incorrectly. You do not need to state radians in this question because they're given in the question.
Okay, so hopefully you did okay in the question, but of course, even if you didn't, even if you got stuck, you have the answer and you're going to continue on with that answer. Find the area of the sector XZWX. So you got to be careful with this and just say to yourself, okay, what exactly does that mean? So you start off here with your XZ, and you're going to say, okay, where's W? W is over here, and then you're back again to your X. So it's actually, I should have used a different pen color here rather than green and green, but you can see where I'm going to, and I'm back here. So it's the sector, the major sector as such here. So, okay, what are we going to do? We need this angle here. This angle here is what we need because that's going to be the corresponding angle for this sector. So what do we do? Okay, we say 2 pi radians is a full circle. So 2 pi minus 2.22 radians, which is alpha, that's going to give me my angle, where the angle is, of course, in radians. The area is going to be a half r squared times that angle. So it's times theta. So in this case, it's a half 4 squared, which is my radius, times 2 pi minus 2.22. And when I multiply it all out, I get 32.50 and so on and so forth. But it says to 1 decimal place, so it's 32.5 centimeters squared, and that was 10 marks.
So this one's marked on a 0, 4, 8, 10 scale. So low partial credit here for 4 marks is work of merit. So that could be finding the angle that you need. So doing the 2 pi minus 2.22, or it could be substitution into the area formula. Either of those would count as low partial credit here for 4 marks. High partial credit is a correct method, but you made one mistake. So if you had accidentally got the angle wrong, but you done everything else right, that would count as high partial credit here, and that would be 8 marks. It is a starred question, so you need to make sure that you have rounded correctly and have the units on there as well. So it is
Okay.
starred.
And of course, I suppose geometry and parts of trigonometry might have been ones that you might not have covered fully before the 12th of March when the schools closed. So you mightn't be that familiar with all this. So the area of the sector. If you're in that situation, of course, you think to yourself, okay, where might I find the formula for that? So you're looking through your table book. So it's on page 9, okay, of your table book, and you can see it here. This is your area of the sector where the angle is in radians. The area is a half r squared theta. So of course, we'd expect a lot of you to be looking through the table book, looking for that. Okay, so here we are now. The logo is shown in the shaded region. Fair enough. Okay, we have that. Calculate to 1 decimal place the area of the entire shaded region. Okay, so we know the area of the sector. So now to get the rest of it, we just need to get the area of the triangle. So the area of the triangle is actually not that bad. We're familiar with this. It's a half one side times another side times the sine of the included angle, a half AB sine C, a half 4 times 6 times the sine of 2.22. That's our angle in radians, alpha. It's 9.55 8. I'm just looking to 1 decimal place, so I don't need to go that far. 9.6 plus my 32.5, which is, I've already found, when I add them together, I get 42.1 centimeters squared. Okay, and that was a 10-mark question.
So this is also marked on a 0, 4, 8, 10 scale. So we're looking for low partial credit here is work of merit. So finding the area of the triangle would be work of merit, or an attempt to find the area of the triangle would be work of merit here. That's for 4 marks. High partial credit for your 8 marks is a correct method, but with one mistake. So if you had used the wrong angle in the area of the triangle, or you had put one of the lengths in wrong, but you had continued then and finished the work correctly, that would count as high partial credit here for 8 marks. And this is again a star question for both rounding and units.
And Andrea, again, if they were in trouble on the last part, so they just made a mistake with the area in part II, and let's just
Mhm.
say they had 25. Again,
Yeah.
can they still get 10 marks in this part if they correctly get the area of the triangle?
Absolutely, yeah. You'll only ever be penalised once for a mistake. So if you got, say, as Owen just said, 25 as his example, and you correctly got the area of the triangle as 9.6, and you added 25 to it, and you got your total, you wrote centimetres squared on the end, you could get full marks here.
So in reality, even though this might be the overall question, kind of getting into it, some people will find that difficult. This part here for 10 marks, really all you were doing was getting the area of a triangle for which you're given the angle in radians
Yeah.
and actually just working out that area and adding it on to a number that you've already gotten. So again, as we always say, it's just about hanging on in there, isn't it? And sticking with the question.
Yeah, absolutely. And I'd also add that if you were someone who found part II very difficult and you didn't try it, so you just said, no, do you know what? I don't know how to do that. I'm letting that bit out. And you got to part III and you thought, okay, I know how to get the area of the triangle and I would know how to get the total area. If you write down an answer in part II and then you use it correctly in part III, you can still get full marks here. So even if you haven't got any workings for your point II, if you've identified an answer in that part and you then use it correctly, you can get full marks in part III.
Brilliant. So, yeah, again, it's the same message. Just kind of hang on. You got to get something in there. Okay. Showed the perimeter of the entire region is 27 centimeters. Okay. So we have a lot of this information already. What we really need to find here is the length of this part. Let me get my, I won't make my same mistake and use my green pen and the green logo. my highlighter, maybe it's not that much better, but this is what we're looking for here. And of course, I know again from page 9, what I'm looking for is arc length here. And my arc length is going to be, I was looking around for it there for a second, but here it is, of course. The length of the arc is the radius times the angle, where the angle is in radians. So here's my formula, r theta, and I actually have everything I need for it. My radius is 4, my angle is the 2 pi minus the 2.22 radians. So we can see here it's 16.25. My perimeter, all I'm doing for that is, okay, I'm adding the 9 centimeters, and then you got to just say you're going to be adding the 2 over here. Where's that 2 coming from? Well, of course, we know the radius is 4, and the length from x to y is 6, so the difference is 2. And we got ourselves 10 marks for that question.
So we're looking at a 0, 4, 8, 10 scheme, and we have low partial credit here is finding the arc length. So any step in the right direction. So if you attempt to find the arc length, that counts for low partial credit here for 4 marks. And our our high partial credit in this case for 8 marks is if you attempted to add your 2 lengths to your arc length. Okay, so a method for finding the full perimeter is your high partial credit here. So even if you accidentally couldn't work out that that WY was 2 and you wrote that as the wrong number, you could still get high partial credit here because you have the correct method. And then full credit obviously is for the full amount. And we are looking for units here. So it is a start question for units.
Okay, so where are we? Okay, so we're on to actually a different part altogether here in part B. I'll just say one last thing about just part A. That I imagine students looked at that, they saw radians, they saw this kind of unusual shape, and they might have been thrown by it. But I'm hoping that you see now that it actually wasn't that difficult once you kind of got started, once you kind of, I suppose, can kind of keep your cool in there and just get stuck into the question.
Oh,
I
and
think,
sorry, can I
yeah, go on,
interrupt and
yeah.
just
You
add
can, of
something
course,
in as
Andrew,
well
yeah.
if you go
Will
back
I go
for a
back?
sec?
Yeah, yeah, no
Yeah,
problem.
I'm actually going to change my mind and say it's not start for units because the units are given in the question. So
Okay.
ignore what I said about it being start for
Yeah.
units.
So it said show that it was 27 centimeters.
Yeah,
So down here, they don't need to worry about if they've said
exactly.
27, it is
Then
fine.
that's fine.
Okay.
Yeah,
Yeah.
they can have full credit there.
Thanks, Andrea. Okay. Part B, the diagram shows a part of the curve with equation y is equal to sine of ax minus b, where a is greater than naught and b is between 0 and pi. Okay, so again, you're still talking about radians here. The curve cuts the x-axis at the points P, Q, and R is shown. Given that the coordinates of P are P, Q, and R are as follows. Okay, so we have pi over 10 comma 0, so that's going to be P. Okay, 3 pi over 5 comma 0, 11 pi over 5 comma 0. Okay, those are my 3 points respectively. Find the values of A and B. Okay, I know some students looked at this and said, okay, on to question 7. I know you did. Okay, you know who you are out there. But again, as we always say, if you don't know what to do, do what you know. You're given some values here. You're given values for x, and you're told the corresponding value for y. So why not just try and sub in the x value and see what happens? Okay, you're saying, okay, in this one here, when the sine of a times pi over 10, so x is the pi over 10, minus b, when you have that pi, when pi over 10 goes in for x, your answer is 0. Okay, fair enough. You get the inverse sine of 0. And in this case here, your answer is going to be 0 for that, the inverse sine of 0. So when you're talking about in the unit circle, the inverse sine of 0, the first answer to that is going to be 0. So you're going to have a times pi over 10 minus b is equal to 0. You bring over the b and you get a times pi over 10 is equal to b. Now you might look at that and go, okay, what am I going to do with that? So you just keep going. You try the next one. You say sine of a times 3 pi over 5 minus b equals naught. So I'm going to get the inverse sine of this. The inverse sine of 0 in this case is going to be the second place where sine is 0 on your unit circle. And we know that happens at 180 degrees or pi radians. So now we'll say isolate B again here. So if I just look at, just to show what happened here, I've just moved B over to the right hand side and I move pi over to the left hand side. Let me just change my pen here for 1 second. My students out there know you know what I'm about to say. I'm about to say the word equate. You're going to equate B. You have because you're saying B is equal to A times pi over 10, and B is equal to A times 3 pi over 5 minus pi. Of course, B is equal to B, so therefore the two left-hand sides in this case are equal to each other. A times 3 pi over 5 minus pi is equal to A times pi over 10. You're looking at it there and said, okay, what am I going to do with that? It still looks awkward with pi and everything, but you just keep going forward. Okay, your A is your variable that you're trying to isolate. You simplify it down. Again, students, even if you got here, some students will struggle with this little bit of maths, right? But 3 pi over 5 minus pi over 10. If you're unsure, you could actually just say it's 3/5 minus 1/10, and that's actually going to give you a 5/10, which is a half. So you're going to get A times 5 pi over 10 is equal to pi. So when you simplify that down, the actual pi's are going to cancel at this point, and 5 over 10, you're actually going to get A over 2 equals 1, and then you get your final answer, A is equal to 2. You don't kind of just don't kind of say I got it now, because you got to get B as well. But B is the easy part if you got here, because you sub in for A. So I'm just going back to my easiest one. I sub in for A, and I end up with B is equal to pi over 5, and that was a 10-mark question.
So this one is a 0, 4, 8, 10 scale. So for low partial credit there for the 4 marks, we're looking for any step in the right direction to solving this. So if you had written your sine of A pi over 10 minus B equals 0, that would be a step in the right direction. So you'd substitute in the coordinates correctly. That would be a step in the right direction. If you had got to as far as having one of the equations, so A times pi over 10 is equal to B, that is still low partial credit. It's still a step in the right direction. So there's lots of places you might get this here. To get your high partial credit in this case, for your 8 marks, we're looking for either A or B correct. Okay, so if you got as far as getting A correctly, that would count for high partial credit here for 8 marks. And then you need both of them correct to be able to get your full marks for this question.
And I suppose it is possible they could have got B before A. It'd be
Yeah,
it'd be hard work to do it, but you could have done it that way. So you could have got B before A and somehow got pi over 5, but not managed to get 2. But I don't think there's going to be many people who did that, I'd say.
yeah, I'd say more people are going to get the A first, all
Yeah,
right.
I think you're right,
Yeah,
Andrea. So look, you know, is that an easy question? I'm going to say no, it is not an easy question. It'd
and
be
I'm going to
inter
agree.
Yeah, it'd be interesting to see how many of you guys out there got it. I think one person got 300 marks, so one person got full marks in paper one. We kind of feel this might be the one that might kind of, I suppose, knock a couple of people off full marks. But you'll know that yourself now after doing the question. Okay,
And I'd
yeah, go on, Andrea.
also add in that it's worth seeing on this question that you might not be able to answer all of that. You
Yeah,
might not be able to get those 10 marks, but certainly you could pick up the 4 marks
yeah.
by just subbing in that first coordinate into the equation that's given to you. So again, reiterating, don't give up on a question, try everything.
That's it. If you don't know what to do what you know. Just do sub in something somewhere. You're on low partial credit. If you're going for a H6 to get low partial credit, Andrew, did you say low partial credit was 4?
Twas, yeah.
Yeah, so you got 40% of this question, and probably one of the hardest questions in the paper. If you got 40% on the hardest question in the paper, you're going to be doing okay. Okay, I think that brings us to the end of this question. So we're going from this and we're going on to question 8, which is another trigonometry question.